Here in this video, we are solving two simple problems in electromagnetic induction. Let's see this first question. It says, in a region of uniform magnetic field, B is given for you 10 power minus 2 Tesla. A circular coil of radius R given for you 30 centimeters. That's an SI system, 30 into 10 power minus 2 meters. Is having an area, having a resistance of pi square ohm, is rotated about an axis perpendicular to the direction of the B, which forms the diameter of the coil. The coil rotates with a frequency of 200 RPM, revolutions per minute, that is 200 by 60 revolutions per second. Frequency is given for you. What is the amplitude of the alternating current induced in this, right? So, we know the formula for the induced EMF equal to minus d phi by dt, that is minus d by dt. Phi is B dot A. If there are n number of the turns, I shall be writing that n, where n is the number of the turns. Of course, here in our case, number of the turns are equal to only 1. By dt, d phi by dt is there. Yeah. So, if you simplify this, minus d by dt, B dot A means BAN cos theta. That theta could be written like omega t, as angular velocity is rate of change of angular displacement d theta by dt for a larger angle theta by t. That implies theta equal to omega into t. So, I can write BAN outside d by dt of cos omega t. In a differentiation of cos theta equal to minus sin theta. You are differentiating with respect to t, so omega is extra factor, so I have to multiply with that basing on a chain rule of differentiation. So, it becomes minus BAN omega, and again minus of minus becomes plus sin omega t. When it is rotated perpendicular to its direction, induced EMF becomes maximum because sin 90 becomes 1. So, it becomes BAN omega, where omega is angular velocity, which can be written like 2 pi into n, where n is frequency. So, we can substitute all the data where this is the formula, induced EMF equal to. Once after deriving the formula, substitution shall become an easy task. Let us do that. Yeah, that implies the induced, you want to calculate actually induced current. This is induced EMF. Once after knowing the EMF, we can write a formula like V equal to IR, current equal to EMF by resistance. So, BAN 2 pi n is the frequency by resistance, where that resistance is given for you. Be careful, this capital N is number of the turns, that is 1, because it is only one coil, that is. This n is frequency, we have already calculated the frequency, number of revolutions per second. Yeah, that implies induced current equal to, what is the formula I have to use? B A, number of the turns are 1, 2 pi n by resistance. Let us substitute that data. B value is 10 power minus 2, area is pi r square, where r is 30 into 10 power minus 2. So, 30 into 10 power minus 2 whole square into 2 pi, n is 200 by 60 revolutions per second, by resistance is given in the problem that resistance equal to pi square. See, this pi square, pi and pi can be cancelled. So, there is no pi in the answer. Wherever there is pi, that can be actually a wrong answer. Let us simplify this. What is remaining? 10 power minus 2, 30 and 30 is 900, 10 power minus 2 whole square is 10 power minus 4, this one, into 2 into 20 by 200 by 60 is remaining. 200 by 60 is remaining. So what we can say, this 2 zeros and this 10 power minus 2 also can be cancelled. This 1 0 and 1 0 also can be cancelled. So what is remaining further? 90 into 10 power minus 4 into 2 into 2 4 divided by 6 is remaining, right? So 3 2's, 3 30's, this is 2 2's, that is 30 into 2, 60 into 10 power minus 4, that is 6 milliamperes. So answer for the problem is 6 milliamperes. That's how we solve this problem, right? Let's have a look at the other problem that is given here. This is given in NEET 2020. It says a wheel with 20 metallic spokes. Number of spokes is 20, but the induced EMF in a wheel is independent of number of spokes. So this data, though it is given, it's not that much useful. Each one is having a radius of 1 meter, that is important for us, rotated with a speed of frequency 120 rpm, revolutions per minute, that becomes by 60 revolutions per second, that is 2 revolutions per second, or 2 Hz is the frequency, that is moving perpendicular to the magnetic field of B equal to 0.4 Gauss. G is Gauss, but 1 Gauss is given as a conversion factor. That need not be given actually, but that was given for us to make our life simple. The induced EMF developed between the axial and induced is how much? We know we have derived a formula for the induced EMF when a rod is revolving in a magnetic field, or when a wheel is revolving, as half B omega L square. Half B omega can be written like 2 pi n and L square. So this 2 can be cancelled. So the induced EMF is B pi n L square. Being all the data is available, this calculation shall becomes an easy task. Induced EMF is B. What's the value of the B is 0.4 into 10 power minus 4. Pi is 3.14. Number of revolutions per second is given for you as 2. L square means just 1 square. So it becomes 0.4 into 2 as 0.8 into 3.14. Of course, these 2 are over. What is remaining is 10 power minus 4. So it will become automatically, I need not calculate 10 power minus 4 if we keep it in the options. All this can be obviously ruled out. 3.14 into little less than 1 means the answer is going to be less than 3. So this is the answer. You can calculate and confirm that too. That much of the induced EMF is developed in the coil. That's how we solve this problem. Thank you for watching.